when you're selecting a NVR, one of the most underrated specs on an NVR. So not the number of channels, not the hard drive size, not even whether it supports 4K. We are talking about just a bandwidth, more specifically incoming bandwidth and outgoing bandwidth. So honestly, this is one of those specs the most people completely ignore when buying an NVR. But it can decide whether your CC system runs smoothly or becomes a laggy, unreliable mess. So let's break it down properly. So NVR, network video recorder, is basically the main hub of an IP CCTV system. So the NVR records that footage, stores on a hard drive, displays it on a monitor. So and lets you view it from your phone, computer or remote monitoring software. So video data is constantly moving in and out of the recorder. So that is where the bandwidth comes into picture. So there are two main type of things you need to understand. Incoming bandwidth is the amount of video data the NVR can receive from your camera. Outgoing bandwidth is the amount of video data the NVR can send out to your mobiles, computer monitors, apps or remote users. That's a simple version if you talk about. Incoming is what comes into the NVR. Outgoing is what goes out from the NVR. Now, why does it matter? Okay, because a lot of people buy an NVR only looking at the channel count. So it could be 4 channel, 8 channel, 16 channel or 32 channel. They think, okay, this supports that many cameras, that's fine. So I'm going to buy this recorder. Price is good and I'm happy with the pricing. Technically, yes, that's okay, that's fine. But that does not always mean it can handle every camera at full resolution, full frame rate and maximum bit rate all at the same time. And that's where people get caught. For example, let's say you have 16 channel NVR. Sounds simple. 16 cameras, done. You can see everything, no problem. But now let's say you are using 16 high resolution 8MP cameras and each camera is sending video at 8 Mbps. The calculation is 16 cameras times 8 Mbps, which equals to 120 Mbps. So your NVR needs to handle at least 120 Mbps of incoming bandwidth just to receive and record those cameras properly without any lagging. Now, if that NVR only supports 80 Mbps incoming bandwidth, you have a problem. So you need to know what's the bandwidth of your NVR. Even though it says 16 channel, the recorder may struggle with 16 cameras at those settings. So you might get camera dropouts, laggy playbacks, unstable recording or missing footages. And the worst part is the system may still looks like it's working until the day you actually need the footage. So if something happens when you want to take a footage, playback, that is why the bandwidth is not just a technical spec. It is a reliability spec. Think of incoming bandwidth like a highway going into a NVR. Each camera is a car sending video data down that particular highway. If you have a small road and too much traffic, everything slows down. Same thing with CCTV. Too many high quality cameras, streams going into a recorder with limited bandwidth can overload the complete system. Now, what affects incoming bandwidth? The first one is resolution. And a 2MP camera uses less bandwidth than 4MP camera. A 6MP camera uses more and 8MP uses even more. So if you are building a high resolution system, you need to check whether the NVR can actually handle it. The second factor is the frame rate. A frame recording at 25 frames a second uses more bandwidth than the same camera recording at 12 or 15 frames per second. So for most CCTV systems, you do not always need cinematic frame rates. In many cases, 12 to 15 frames per second is more than enough. The third factor is the bitrate. Bitrate is basically how much data the camera uses to create the video stream. Higher bitrate usually means better image quality, but it also means more bandwidth and more storage use. So when people set every camera to maximum bitrate, maximum frame rate and maximum quality, they're also increasing the pressure on the NVR and the hard drive. The fourth factor is compression. Modern systems usually use H.265 or H.265 plus. Older system may use H.264. H.265 is more efficient, which means it can reduce bandwidth and storage compared to H.264, depending on the scene and settings. So two cameras with the same resolution can use very different amounts of bandwidth depending on compression. The fifth factor is the scene itself. A camera looking at a quiet will use less bandwidth than a camera looking at a busy road. So more movement and more details mean more data. So bandwidth is not always fixed. It can change depending on what the camera is seeing. So now let's talk about outgoing bandwidth. Outgoing bandwidth is what the NVR uses when someone views the system. So when you have a playback and all those things. For example, when you open your cameras on your phone, the NVR sends video to your phone. When someone views the system on a computer, the NVR sends video to the computer. When a business has multiple managers and remote monitoring or a control room for that matter, all of that uses outgoing bandwidth. So incoming bandwidth is mainly about recording. The outgoing bandwidth is mainly about viewing. Let's say one 8MP camera mainstream uses 8 Mbps. If you open 8 cameras in high quality, that could use around 64 Mbps outgoing bandwidth. So now if another person opens the same 8 cameras in a high quality from another location, the NVR may need to send 64 Mbps. So this is now becomes 128 Mbps going out of the NVR. So if your NVR supports say 80 Mbps outgoing, generally the outgoing bandwidth, the system may start buffer, lagging or switching to a lower quality. So that's why mobile apps normally use something called a substream, mainstream and substream. So normally when you do it on mobile apps, you select the substream. So most IP cameras have at least 2 streams. That is called the mainstream, is the high quality stream used for recording. The substream is the lower resolution stream used for live view. So especially when you are looking at multiple cameras at once on a phone. So when you open 16 cameras on your mobile app, you are usually not watching a 16 full resolution 880p cameras at the same time. You are watching the substream. So and is a good thing, because on a small phone screen you do not need every camera loading at full resolution in grid view. It would waste bandwidth, slow down the app and use more internet data. When you tap one camera and switch to HD mode, the app can load the mainstream for better detail, so that rather than sitting on a substream. So that way you can see the picture in a clear quality. That's how a well-designed system balances quality and performances. So now outgoing bandwidth also depends on your internet connection also. So this is very important. Your NVR might support 100 Mbps outgoing bandwidth, but if the internet upload speed at the site is only say 20 Mbps, then your remote viewing is limited by that particular internet, not the NVR. So for remote viewing, there are 2 things to check. So the NVR outgoing bandwidth and the site internet upload speed as well. So if you have a business with multiple people viewing cameras remotely, this matters a lot. Now let's make this simple. Incoming bandwidth answer this question. How many cameras can NVR record at this quality? Outgoing bandwidth answer this question. How many users can view the system smoothly? This is the core difference on any system. Let's talk about PoE backed up NVR. So a PoE NVR has network ports built into the back of it, and you plug cameras directly into the NVR using Cat5 or Cat6 cables, and the NVR provides power and data through the same cable. So very clean, neat setup, straightforward, but bandwidth is still matters. Just because an NVR has an 8-port PoE does not mean you can connect 8 extremely high bitrate cameras and expect to perfect performances. The recorder still has an incoming bandwidth limit. So the same applies if you use a separate PoE switch, whether the cameras are connected directly to the NVR or through a switch, the video still needs to reach the NVR. The recorder still needs enough capacity to receive and record those streams. So now let's do a few real world examples. Say take 4 cameras. If each camera using 6 Mbps, so 6 into 4, 24 Mbps. So that's easy for most modern NVRs. Take another example, 8 cameras. If each camera is using 8 Mbps, so 8 times 8, it will be 64 Mbps. So your NVR needs more than 64 Mbps incoming bandwidth. Ideally, you want extra headroom, not just the exact number. And this is where cheap NVR can become a headache. So this might support number of channels, but not the real world load. So now bandwidth also affects storage. This is another big one. So if a camera records 8 Mbps, it uses roughly double the storage of a camera recording at 4 Mbps. So if you increase bitrate for a better quality, you also need a large hard drive if you want the same number of recording days. So that means when design a CCTV system, you can look at just one thing. You need to think about camera resolution, camera bitrate, frame rate, compression, number of cameras, and NVR incoming bandwidth and NVR outgoing bandwidth, hard drive size, recording days, remote viewing, internet upload speed, and AI features and local display performances. This is why a proper CCTV system is designed as a full system, not just a shopping list of cameras. Now let's talk about common symptoms of bandwidth problem. If incoming bandwidth is too low, you may see cameras randomly disconnecting on and off here and there. So you may see laggy live view. You may have recording gaps. Playback may become choppy. The NVR may struggle when all cameras are active. Or the system may lower stream quality to keep running. A lot of people blame the cameras, the cable, or the hard drive, or the internet. Yes, those can definitely cause problems as well. But sometimes the real issue is the NVR which you selected is been overloaded. Now, if outgoing bandwidth is too low, the problem looks a bit different. Remote view may buffer. The app may take a long time to load as well. Multiple users may struggle to view cameras at the same time. The video automatically switch to lower quality. Playback from the phone may feel very slow. So you may blame the system, you may blame the manufacturer, or the system may work fine locally but feel terrible remotely. That is usually an outgoing bandwidth of internet upload issues or internet issues. So now there's another spec that confused with bandwidth, and that's the decoding capacity. Decoding capacity is about how much video the NVR can display, especially on a monitor connected directly to the NVR. An NVR might be able to record 16 cameras, but it may not be able to display all 16 cameras at full 820p quality at the same time on a load screen. That does not always mean something is wrong. In multiple camera wave, the NVR may use lower quality streams to make the display smooth. So remember these three things. Incoming bandwidth is for receiving and recording. Outgoing bandwidth is for sending videos to users. Decoding capacity is for displaying the video. So they are all related, but they are not the same though. Now let's talk about AI cameras. These days, the modern CCTV systems often include features like human detection, vehicle detection, perimeter protection, face recognition, and smart search, TIOG, VisSense, AccuSense, ColorView, VisColor, AccuPick, and more. So these features are great, but you still need to check the NVRs, capabilities and capacities. Some AI processing happens inside the camera. Some AI processing happens inside the NVR. Some systems support both, but within the limitation. So when choosing an NVR, do not only ask how many cameras does it support. Simply ask how many AI channels does it support. Does it support AI by camera or by recorder? Does it support smart search? Does it support the camera features that you are buying? Can it handle the required resolution and bitrate? This matters a lot if you are building a real serious system. Now here is the simplest way to choose the right NVR. Before you purchase it, first count how many cameras you need. Then you check the resolution of those cameras. Thirdly, estimate the bitrate per camera and multiply the number of cameras by the bitrate. So that gives you approximately incoming bandwidth requirement. So then compare that number with the NVR's incoming bandwidth rating. Don't run it right at the limit. Always leave some headroom, so some space so that you can play around with. For example, if your cameras need 128 Mbps, choosing a 160 Mbps NVR is much better than choosing an NVR only just meets that number. Especially for commercial jobs, even more headroom is much better. So here is the takeaway. Do not buy an NVR just because it has enough channels. Check the bandwidth. Incoming bandwidth tells you how much camera video the NVR can receive and record. Outgoing bandwidth tells you how much video the NVR can send out to users. So mainstream is usually for high quality recording. Substream is usually for smooth live view, especially remote viewing. Higher resolution, higher frame rate, higher bit rate and more movement all increase bandwidth. And remote viewing also depends on your internet upload speed. And if you are using AI cameras, check the AI limits as well. So next time you are looking for an NVR, do not just ask it's a 8 channel or 16 channel. Ask what is the incoming bandwidth and can it actually handle my camera properly. That's the difference between a system that only works on a paper and system that actually works in the real world. So, and another thing, that's what we focus on CCTV Trivia. So we help you match the right cameras, the right NVR, the right hard drive and the right accessories. So your system is not just high resolution but also stable, reliable and properly designed system. Anyway, so I think we covered most of the thing about the incoming and outgoing bandwidth today. So thanks for watching, and if you need any help choosing the right NVR for your home, business, warehouse, for commercial project, visit CCTV Trading.